Good afternoon. I am Abdul Rahman Dannaoui, and the title of my research activity is Information Integration for Biological Data Sources. My tutor is Professor Domenico Beneventano. My co-tutor is Professor Nicola Piccioni. During the last 3 years, my research activity is founded by Centro Interdipartimentale Biologia CITEA and aims to realize a serial database that perform biological data integration, more precisely phenotypic and genotypic data, phenotypic and genotypic serial data, and to study the data provenance in the context of data integration systems to to implement a provenance management component for the MOMIS data integration system. Data integration is the process of combining data from different sources by giving the end user possibility to have a unified view of the entire available information. Data provenance is the process of identifying where data came from, how it was derived, and how it was updated. So during this presentation, I will present some functionalities of the MOMIS system to underline how the data fusion is performed by means of new operator called full join merge operator. And I will present the serial database obtained by using the MOMIS system. Then I will present the data provenance and the context of data integration system to then define the provenance for the full join merge operator, and so its implementation in the MOMIS system. Finally, I will, through an example, I will show how the provenance is computed in the actual version of the serial database, and I will present the main contribution of my research activity and the possible future work. So in this slide, there is a brief description of the MOMIS data integration system. MOMIS is a mediator environment for multiple information sources and is a framework to perform information extraction and integration of heterogeneous data sources. The proposal of MOMIS is to provide a unified view of a unified description of information from different heterogeneous data sources by means of a global virtual schema. Such global schema allows user to raise a query and to receive a single unified result from the data sources. Main aspect of the MOMIS system is semantic integration of information and tool supported techniques to construct the global schema. An open source version of the MOMIS system is currently released by Data River, a startup company of our university. So, starting from the involved local sources, the integration designer builds the global schema. The mapping among a global class over its local sources, it's defined is represented by a mapping table. There is an example of a mapping table. We have two local classes corresponding to two local tables, and the mapping table to construct the global class is presented in this image. Some attribute have a one-to-one mapping, but in general a global attribute is mapping into. Ma perché sta cambiando così da solo? Sta cambiando da solo slide.
Because it was changed to slideshow during the break, so you should stop the slideshow because the posters were shown automatically on the screen during the break and the break. So.
So The MOMIS system used a global as view approach for mapping specification. So for each global class, a query is defined over its local classes. An important task of data integration is data fusion, the process of using multiple records representing the same real-world object into a single consistent representation. To perform data integration, we use a new operator called the full outer join merge operator. In this slide, there is an example to show how data fusion in MOMIS is performed by means of the new operator, full join merge operator. This operator is compounded by the standard full join operator and use the resolution function to perform the merge process. First, I will take the example of a non-conflict attribute. So one-to-one mapping. We have two local classes, L1 and L2, integrated into the global class G. In this case, the full outer join merge operator is corresponding to the standard full join operator because we don't use the resolution function. While in this case, it's more complex because we use the resolution functions. So in the case of the column C, resolution function average is used to resolve data conflict between two columns C from the two local sources L1 and L2. After the introduction of the MOMIS system, I can introduce the first topic of my research activity, the integration of biological data, so the implementation of the serial database. This activity is performed in collaboration with the Facoltà di Agraria dell'Università degli Studi di Modena e Reggio Emilia. So the problem was the integration of different open source databases that deal with phenotypic and genotypic data separately in order to offer to the breeders the possibility to access this data by using a single tool. So our solution was to use the MOMIS data integration system to integrate these data sources and to create the serial database. The serial database now store phenotypic and genotypic data for three cereal species, wheat, barley, and rice, collected within the serial project, and integrate them with data coming from well-known open source databases as Green Genes and Gramene. This is an example of the global class germplasm obtained by fusing two local classes, GPA and GPB. The first one store information about germplasm collected within the cereal project. The second one stored information about germplasm coming from other open source database. So to fuse this, first we have a shared object identifier, GPN. And we have three conflict attributes, yield, FHB, and type. And to fuse these two local classes, we use the full outer join merge operator with the application of resolution function as the case of the FHB column. For example, to prefer values from the first local source. Okay. The integration of phenotypic and genotypic data was realized in the first version of the serial database, which was realized by Antonio Sala in his PhD work. Starting from the first version of the serial database, several extension and improvement was implemented. First of all, I implemented a breeder-friendly interface with many functionalities. These functionalities have been reported by two seed companies, SAIS, Società Italiana Sementi, and PSB, Produttori Sementi Bologna, as the most important functionalities for the breeders to perform their activity. Moreover, new functionalities for the serial lab researchers has been implemented. I implement a new module to insert the new data obtained by the serial lab user. by the new experiment. So by using the MOMIS system to integrate this data, the new data is immediately available in the next interrogation. Other extension was the integration of new available data sources and the integration of a new release of existing data sources as Gramine and green genes. The Serap database is online and is a very useful tool for many researchers and breeders from different seed companies and different research groups. The work on the Serap database have been published in these four publications. Now I will introduce the data provenance in the context of the data integration system to show how we define the data provenance for the MOMIS, for the full join merge operator, and so its implementation in the MOMIS system. So data provenance is describe where data come from, how it was derived, and how it's updated over time. An important aspect in data integration is an important aspect in data integration is the correctness of data. So when we receive a query result, we need to know the origin of the data to determine if they are reliable. A recent tutorial listed data provenance as one of the open problem and desiderata for data fusion system. Another reason behind the study of data provenance in the Serap database was the need of the Serap user to visualize the origin of the data and to have an explanation of the merging decision. So after the next step after the realization of the Serap database was the implementation of a provenance management component for the MOMIS system to offer this information. So in the literature we found several models of provenance. The most classical models used in the context of the database are the classical lineage that encode the tuples that were used in some derivation of the query result. So the result is a set of tuples, and the more complex Y provenance that encode all the different derivation of a tuple in the query result. So the result is a set of tuple. But none of these models provide a fully solution for the MOMIS system, because in the MOMIS system we use the full join merge operator that it's more expressive with respect to the union of conjunctive query. A more recent model called perm influence provenance that deal with the full outer join operator provide more precise information with respect to the other models, and an open source system called PERM is implemented. Through this example, I will show the provenance, the PERM influence provenance as a set of witness lists. First, a witness list contains a local tuple from each local class, or the special bottom, the special value bottom, indicating that no tuple from a local class was used to derive the output tuple. The notation L11 denotes the record with ID equal 1 from the local source L1. So in this case, we have two local classes, L1 and L2, with non-conflicting attribute. If I pause this query, the result will be as shown in this table on the right. So for the first output record A equals 3, the witness list the set of witness lists contain just one witness list, and this witness list denotes that the record with ID equal 1 and the record with ID equal 1 from the local source L1 and the local source L2 have been used together to derive the output tuple. While in the second case, we have two witness lists. So the second witness list represents that the output tuple A equal 12 can be obtained by just using the record with ID equal 4 from L1, with no other tuple from L2. In this case, the perm influence provenance provide a full solution for the full join merge operator, because in this case, this operator corresponding to the standard full join operator. The problem is in the case of using resolution function, because the perm influence provenance not encode all different derivation of a tuple inquiry result. Our solution was to extend this this model to deal with the full join merge operator in presence of resolution function. The formal definition is presented in the thesis, and through an intuitive example, I will explain the idea of this extension. So, if we have two local classes, in this case L1, L2, and we have a conflict attribute A, if I pose this query, the result of the perm influence provenance will be as shown. For example, for here for A equal 12, the result is a set of just two witness lists, while the derivation of all possible derivation must include also the witness list L13 and button, because we can obtain this result I equal 12 by using just the local tuple with ID equal 3 from the local source L1. So to implement a provenance management component for the MOMIS system, we use the perm system as a SQL engine of the query manager of the MOMIS system. So we can obtain the data provenance information in the case of using the full join merge operator without using the resolution function. To obtain data provenance information when we use the full join merge operator with the resolution function, we need to implement the extension to the perm influence provenance model. The work on this on the data provenance in the context of data integration system have been published in these two articles. The last point of my presentation, in the last point of my presentation, I will present through an example how data provenance is obtained by using the actual version of MOMIS with the perm system as a SQL engine of the query manager. So let's take the global class Genplasm from the serial database. As I said before, we have two local classes with a shared object identifier GPN and three conflicting attributes. So if users want to see the provenance the provenance of the query that search all varieties that are resistant to Fusarium head blight, the result without provenance will be like this. The result with provenance information, for example, in the case of cultivar, where we have a set of two witness lists, in the MOMIS system is presented like this. So if I pose this query on the actual version of MOMIS with the perm system, the result will be like this in a relational form. So so each witness list is presented in a single is presented as a single record. So if I take the case of cultivar, we have a set of two witness lists. So the result is two record, and this is the actual output of interrogating the MOMIS plus perm system. This work have been published in these three publications. Okay. The main contribution of my thesis are the realization of the serial app database to offer to the breeders a unique tool that stores genotype and phenotypic data with a breeder-friendly interface, and the study of provenance model to then identifying the perm influence provenance as the most suitable provenance model for the MOMIS system, and the presentation of a possible extension of this model to deal with the full outer join merge operator in presence of resolution function, and finally the design and development of a provenance management component for the MOMIS system. As a future work of my research activity, the first thing can be the implementation of the extension to the perm influence provenance to deal with the full join merge operator in presence of resolution function. So in the Serial interface, you can provide users data provenance information, and it could be of interest to study other complex data provenance model to see how they can be applied in the case of the full join merge operator. This is a list of the list of my publication. Thank you for your attention.
Thank you very much for your talk. Any questions?
Future development on the topic of relevance?
As I said before, it could be of interest to study other provenance model to see how they can be applied to the full join merge operator.
Okay, thank you very much again. And we proceed with the next candidate, is Miss Karina Panusia-Tillen. And then we have another candidate for this afternoon. And after that, we will start the second part of this afternoon concerning the presentations given by the students of the 26th cycle.
The presentations were slide today.
I think so. Okay, first day. Let's see. Is there anybody who knows where all the presentation files have been saved?
In the sense.
Do you have a...
non ho messo una cavetta. Posso scaricare dal sito?
Yes.
Okay.
We are connected to the internet, so you can do a download. Sure.
Okay, can go. Sorry.
No problem. Okay.
Non mi ricordo se era...
Yes, WW. Okay. Username and password. Is there anybody? You can...
no, devo entrare io la mia bacheca. Ok, uso questo mouse. No, allora qual qua? Questo italiano. Scrimi intero. Ok.
Grazie.
Ok, sente?